So this is the first lesson in Unit 5.6. Unit 5.6 is called Proportional Reasoning. So what we're going to cover in this unit is we're going to cover ratios, equivalent ratios, proportions, and we're going to spend a bit of time looking at word problems that you can solve using ratios and proportions. But to start with, this lesson is just going to cover some material from Box A. We're going to look at what ratios are and how we can write them. And we're going to look at some of the stuff from Box B where we talk about what equivalent ratios are. So let's start with ratios themselves. A ratio is simply a way of comparing two quantities. So we'll say it's a comparison of two quantities. And usually these quantities are just numbers. So here's an example. Suppose the ratio of students to computers in a school is 5:1. This right here is our ratio. And we have to think about what the 5 represents and what the 1 represents. Well, the 5, if the ratio is students to computers, this is going to be our students. This is our number of computers. So this means that there are 5 students for every 1 computer. In the school. Now, we can write this ratio in a few different ways. We've written it as, we can write it using words as sort of 5:1. This is in words. We can write it as a ratio, like we did up there with the 2 dots in the middle, 5:1. Or we can write it as a fraction. And when we write it as a fraction, we're going to put the first number, the 5, up on the top, and the second number, the 1, down at the bottom or in the denominator. So let's just take a look at a few more examples of simply working with ratios. We've got a little picture here with a bunch of circles and stars. The ratio of circles to stars is, well, let's see, we've got to count them up. We count up the number of circles, 1, 2, 3, 4, 5, 6, 7, 8. We have 9 circles. We count the number of stars. There are 6 stars, so the ratio of circles to stars is 9:6. Or we could write that as 9/6. If we want to look at the ratio of circles to all shapes, well, let's see, we have 9 circles. How many shapes do we have in total? Well, that's the number of circles plus the number of stars, so we have 15 shapes in total, so that'll be 9:15. Or 9/15. Ratio of stars to all shapes, well, again, 6 stars, 15 shapes. So 6:15 or 6/15. So those are ratios. Now, the next thing we have to talk about is what are meant by equivalent ratios. Equivalent ratios are ratios that are different, but they make the same comparison. So they're expressing the same comparison just with different numbers. And we'll see what we mean if we look like an example. Suppose a class of 30 students has 6 computers. The ratio of students to computers is, well, let's see, students to computers, there are 30 students. There are 6 computers, so that ratio is 30:6. Okay? Now, we can take, if we want to find a ratio that's equivalent to this, we can take each of these 2 numbers here and find a number that'll divide evenly into both of them. Sort of put the ratio in simplest forms, or put our fraction in lowest terms. So I can take my 6, and I can divide it by 6. To get 1, I can do the same thing to that number 30. I can divide it by 6 to get 5. So the ratio 30:6 is equivalent to the ratio 5:1. So this ratio is equivalent to 5:1. Okay? And to find an equivalent ratio, one of the easiest ways to do it is just multiply each term in the ratio by the same number. So if I've got 2 to 8 here, and I take my 2 and I multiply it by 2, I get 4. If I do the same thing to the second term here, take my 8, multiply by 2 to get 16, I've got myself an equivalent ratio. So therefore, 2 to 8 and 4 to 16 are equivalent ratios. So we can multiply each term by the same number, or we can divide each term by the same number. So if I've got 2 to 8 here, I want to find a number that will divide evenly into both of these. I don't want decimals or fractions in my equivalent ratio here. So I think 2 will divide evenly into both of these because these are both even numbers. So I can take my 2, divide it by 2 to get 1. I can take my 8, divide it by 2 to get 4. So I get the ratio 1 to 4. Therefore, 2 to 8 and 1 to 4 are equivalent ratios. Okay. So let's practice here. Determine an equivalent ratio by multiplying. Well, let's see. I can multiply each of these things by 2. So I'll multiply my 1 by 2 and my 2 by 2, and I'll get the equivalent ratio 2 to 4. I can take my 7 to 5 here. I can multiply the 7 by 3. And multiply the 5 by 3. And I can pick any number I want to do this multiplication here, as long as I don't choose 1. So 7 times 3 is 21. 5 times 3 is 15. So an equivalent ratio there is 21 to 15. Down here I can divide. Let's see. Let's think about what I can divide into each of these. Well, I can divide 7 evenly into both 7 and 28. So I'm going to divide by 7 here to get 1, and divide by 7 there to get 4. So my equivalent ratio is 1 to 4. And this one here, let's change it up a little bit, and let's take our ratio and we'll write it in fractional form. 45 over 15 to get an equivalent ratio. Again, this is like putting this in lowest terms, let's say. I can divide the top by 15. I can divide the bottom by 15 to get 3 over 1. Okay. So this discussion of equivalent ratios leads us nicely into what we mean by simplest form. A ratio is in simplest form if there's no number that will divide evenly into each of the terms, and each term is a whole number. So this is just like putting a fraction in lowest term. So if I see a ratio 7 to 2, I ask myself, can anything divide evenly into the 7 and the 2? And the answer is no. So this one is in simplest form already, so we don't have to do anything here. What about the next one, 18 to 6? Well, I know that 18 is divisible by 6, and 6 is divisible by 6. So let's put this into simplest form. I'm going to divide by 6 here to get 3. I'll divide by 6 here to get 1. So my simplest form is 3 to 1. The next 3 are all slightly different ratios because they have 3 terms in them. Here, in a 3-term ratio, we're comparing 3 numbers to each other. So 1 to 5 to 3. We can put them in simplest form the exact same way. We just have to do the same thing to each of the terms. So 1 to 5 to 3, no number divides evenly into all 3 of those. So this is already in simplest form. So we'll just say simplest form. Our next one here, 3 to 9 to 12, all of those numbers are divisible by 3. So we just have to divide each of these by 3. So we'll have 3 terms here, divide by 3 to get 3, divide by 3 to get, that first one, when we divide by 3, we should get 1 there, because 3 divided by 3 is 1. We divide 9 by 3, we get 3, and we have to divide the 12 by 3 as well to get 4. So our equivalent ratio is 1 to 3 to 4. Now, here we've got a ratio where we have a decimal in it. The easiest way to get rid of that decimal is to divide it by itself. So we're going to come up with an equivalent ratio here, 3 terms, And I know to get rid of this 0.5, I'm going to divide it by 0.5. Because 0.5 divided by 0.5 is any number divided by itself is just 1. So now I'm going to do the same thing to my other two terms. Divide 4 by 0.5, and I punch that into my calculator, and I find that I get 8, and I'm going to take my 3, and divide it by 0.5, punch that into my calculator, and I get 6. So my equivalent ratio there is 8 to 1 to 6. And that's equivalent ratios.